You've probably admired the images from the James Webb Space Telescope, those sharp portraits of galaxies, nebulae, and distant stars that make the universe feel alive with detail. But here on Earth, something new has begun to rival even Webb's achievements. High in the Chilean Andes, a brand new observatory has started to take its first images, and they are extraordinary. It's called the Vera Rubin Observatory, and after years of design and construction, it has finally opened its eye to the cosmos. If you remember my video from a few years ago about an ambitious telescope that hardly anyone was talking about at the time, this is it. Now, the wait is over and Rubin is delivering on its promise. The observatory sits on Cerro Pachón Mountain in northern Chile, at an altitude of about 2,700 meters. This location was chosen for a reason. The Atacama Desert is one of the driest and clearest places on Earth, with skies so dark that the stars stretch across the horizon in a way that few of us will ever experience. These conditions, combined with the altitude, make it one of the best places on the planet for astronomy. It's no surprise that this same region is home to some of the most advanced observatories in the world. Inside the Rubin Observatory is the Simony Survey Telescope, which is paired with the largest digital camera ever built. The camera is a remarkable piece of engineering. It's about the size of a small car, weighs nearly 3 tons, and produces images containing 3.2 billion pixels each. To put that into perspective, it would take almost 400 4K televisions to display a single Rubin image at full resolution. And it doesn't just take one picture per night, it will generate around 20 terabytes of data every night. That's so much information that a dedicated 100 gigabit per second fiber optic connection had to be built to transfer the data from Chile to the United States, where it will be processed and stored. So what makes Rubin so special? Other telescopes like Hubble or Webb also capture stunning images, but Rubin's purpose is a little different. Its mission is the Legacy Survey of Space and Time, or LSST for short. Over the course of 10 years, Rubin will map the entire southern sky over and over again, building a kind of cosmic time-lapse. While Webb focuses on narrow, deep views of the universe, Rubin is designed to cover huge areas quickly, capturing changes as they happen. The telescope achieves this thanks to its unusual optical design. Most large telescopes use 2 mirrors, but Rubin uses 3. This design allows for a wide and sharp field of view. Each image covers about 10 square degrees of sky, which is roughly 40 times the area of the full moon. To compare, Hubble's field of view is about 1% of the moon's surface. Rubin can image 4,000 times more sky in a single exposure than Hubble can. That scale is what sets it apart. And this isn't just about scale. By scanning the sky repeatedly, Rubin can track how things change over time. Stars that brighten and fade, asteroids that move across the sky, galaxies colliding, supernovae exploding, Rubin will catch them all. Every 3 nights, it will have imaged the entire southern sky, something no previous observatory has ever achieved. The first test images, released in June 2025, already show the power of this approach. One of the highlights is a mosaic known as the Cosmic Treasure Chest. This image covers a section of the Virgo cluster, the closest large cluster of galaxies to the Milky Way, about 55 million light-years away. The mosaic was stitched together from more than 1,000 exposures taken over 7 nights. Within it, astronomers can see a dazzling variety of galaxies, spirals, ellipticals, and interacting groups, as well as millions of stars. Just this single image contains around 10 million galaxies, and that is only a tiny fraction of the 20 billion galaxies Rubin is expected to catalog over its lifetime. Another striking early image shows the Lagoon Nebula, a massive star-forming region about 5,200 light-years from Earth. Hubble has observed the lagoon before, capturing fine details of its structure, but Rubin's field of view lets us see the whole nebula at once, along with its neighbors. The mosaic reveals not just the lagoon, but also the Trifid Nebula, the open cluster Messier 21, and even a globular cluster called NGC 6544, all within the same frame. By combining exposures through different filters, Rubin reveals details that the human eye cannot see, turning faint gas and dust into vivid structures. These early results are impressive, but they also hint at the science to come. Rubin has 4 main goals: to investigate the mysteries of dark matter and dark energy, to catalog and track solar system objects such as asteroids and comets, to monitor transient events like supernovae and gamma-ray bursts, and to map the stars of the Milky Way in greater detail than ever before. Even during its early tests, Rubin discovered more than 2,000 new asteroids, including 7 near-Earth objects. For comparison, the combined efforts of all other telescopes typically discover about 20,000 asteroids per year. Rubin is expected to identify millions in just its first 2 years. It may also give us our best chance yet to spot interstellar visitors like Taumu or Borisov, which are thought to pass through our solar system roughly once a year. The observatory has also begun detecting variable stars, including a type called RR Lyrae stars, which astronomers use to measure distances across the galaxy. Rubin is expected to find hundreds of thousands of these stars, which will help us map the outer structure of the Milky Way and perhaps even uncover evidence of past galactic mergers. Over the course of the survey, Rubin will generate more than 500 petabytes of data. That's 500,000 terabytes, making it one of the largest datasets ever created in astronomy. Scientists will be working through it for decades, and much of the data will be available to the public as well, giving anyone the chance to explore the night sky in extraordinary detail. For me, what makes Rubin so exciting is not just the scale of its images, but the way it will change how we study the universe. Instead of static snapshots, we'll have a dynamic record of the sky, showing us how stars, galaxies, and other objects evolve over time. It will be like watching the universe in motion. The observatory is named after Dr. Vera Rubin, who discovered some of the first evidence for dark matter in the 1960s. At the time, women were rarely seen in astronomy, and she pursued her research while also raising a family. Her work changed physics forever, and it's hard to imagine a more fitting tribute than an observatory that will probe the very mysteries she helped uncover. These first images are just the beginning. As Rubin moves into full operations, it will give us a new way to see the universe wide, detailed, and alive with change. It will show us billions of galaxies, track millions of asteroids, and capture cosmic events as they happen. Like Dr. Rubin's work, it will reshape how we understand the cosmos. And we get to watch it happen.